Okay, in lab 8, we're going to construct tangents to a circle, and there's two different constructions. The first one is through a point that's on the circle itself, and the second one is through a point that's not on the circle. So I'm going to do each of the constructions twice. The first time, I just want you to watch me do it. And then the second time, I want you to grab a piece of paper and your compass and your protractor and follow along with me. But the first time, just watch me do it so that you have the idea in your mind already of what I'm doing. And then follow along with me the second time. Okay, so first of all, through a point on a circle. So the first thing we're going to do is draw ourselves a circle with our compass. So get your compass, draw yourself a circle. I'll say this is circle with center P, and I would like to make a tangent here at point A that's on the circle. So this is through a point that's on the circle. Okay, so if you think about the theorems we know if we draw a tangent to point A, that it will have to be perpendicular to any line that goes through the center. So that should give us a clue of how we're going to do this instruction. So we're going to take the center of the circle, okay, and draw a line through point A. And now if I can construct a perpendicular to that line that goes through the center at point A and get that 90-degree angle, that has to be tangent. Okay, so that's our goal. So how do we construct a perpendicular to a point? Well, we've done this in a previous construction. What we're going to do is open up our compass, okay, go to point A, and then mark off, okay, two segments that are equidistant. Okay, so our 2 points equidistant from A on either side. It doesn't matter how big your compass is as long as they're exactly the same. Okay. And then from those two intersection points, I want to make sure that I open up my compass so it's more than halfway, so it can't be here. It has to be more than half the length between those two arcs. And I'm going to mark, I'm going to go pretty wide. I'm going to go above and below the line from the first intersection point, and then I'm going to do the same thing above and below. And so I should get these two. Sorry, this one didn't go. Okay, and so if all went well, when I line up the two X marks the spots, okay, it also should go through A. It should be perpendicular to the line that we drew through the center at the point A, and therefore tangent to the circle. Okay. So that's the first construction, through a point on the circle. Okay, so I want you to grab your blank piece of paper, and at the top you're going to write Lab 8. And this is your practice. So this is Lab 8 practice. And label this first one through point on circle. Okay, so label it that way, and then draw yourself a circle. You can just do it right in the center of the page, but make it on the top half of the page. Oops, I got a little wiggle in mine. All right, so I'm going to label my point P. All right, and now I'm going to pick a point on the circle. Let's just go ahead and label it A. And then you want to draw a line that goes through the center of the circle as well as point A. Okay, so I'll get it nice and long. And then you're going to want to draw the perpendicular bisector at A. So open up your compass to a random length and mark off equal segments on both sides of A. Okay, I'm just going to go ahead and label these X and Y so I can talk about them with you. Okay. And then open up your compass nice and wide. Okay. And then from point Y, I want to go above this line, above point A, and below the line below point A. And then from point X, I want to do the same thing, go above and below. And you should get 2 nice X marks the spots. And when you line those up, they should also go through point A. If they don't, you've done something wrong. So notice my point X was pretty close to P. Okay, don't go from P. P is irrelevant. Okay, make sure you go from X and Y, the 2 ones that you marked off. The only thing P is ever used for is to make sure that the line that I originally drew, it has to go through there. I'm never going to use P again. Okay. All right, so you should have a nice tangent line. Okay, so that's our first practice for Lab 8. Now let me show you how to do a point, tangent through a point that's not on the circle. Okay, so I'm going to draw a circle. Let me make sure you can see it. Alright, so I got my circle. Again, I'm going to call it circle P. Okay, and this time I'm going to choose a point out here. So point A is not on the circle. Okay, and so I am going to once again draw a line through the center that goes to point A. Okay, so like that. And now I want to find the midpoint of AP. So to find the midpoint, I need to calculate or find the perpendicular bisector of AP, and then wherever that perpendicular bisector crosses the line will be my midpoint. All right, so to find the perpendicular bisector, I do an arc above and below the line from one end point, so from A, and then the other end point of the segment I'm trying to bisect, so from P. Okay. And then if I were to connect the 2 X marks the spots, okay, the point right that I would go through, that's the midpoint. I'm just going to label that M. Now you can draw the whole line in if you want, but really we're only interested in M. So I'm just going to mark M as the midpoint so my picture isn't too much of a mess. Okay. And now I'm going to take and I'm going to measure from M to the center, M to P. Okay, and notice that should be the same as M to A because this is, after all, the midpoint. Okay, and so using that radius, I'm going to mark off 2 points on my circle. Okay, so one over here and one over here. Okay, so I'm going to call this one B and I'm going to call this one C. Okay, and both of those will be places that will give me tangent lines. Okay, so if I go from here to A, that will be a tangent line, and if I go from A to C, that will be a tangent line as well. Alright, so both AB and AC will be tangent lines. Okay. Alright, so grab your Lab 8 practice sheet, okay, that you did your first practice on, and we're now going to work on another practice problem, but this time it's going to be through a point that's not on the circle. Okay, so label that one through point not on a circle. Okay, and draw yourself a circle again. You can just kind of draw it right in the bottom of that page. Okay. And go ahead, if you want to, you can label the center point P. Alright, and now I'm going to pick a point out here. So I'm going to pick my point A that's not on the circle. Okay. And then I'm going to draw a line that goes through P and A. And if you want to make it go just straight from PA and don't make it extend beyond there, that might be a good idea so that you're not distracted by the rest of the line, because AP is the thing that we want to bisect. Okay, and so if you don't have too much line, that might help you. Okay, so now that you have AP, we need to construct the perpendicular bisector of that so we can get the midpoint. Okay, so I want an arc that's above and below AP from A and above and below AP from P. Okay, and so if I connect those two, X marks the spots. Okay. The only point that's really important to me is this point here, the midpoint. Okay. If you want to draw the whole line in there, if that's helpful, you can go ahead and draw the whole thing in. Okay. So if that whole thing is helpful to you, you can draw the whole thing in, but the only thing that's really important is the midpoint. Okay. And so that midpoint, why don't you verify that the distance from M to P and the distance from M to A are the same. So M to A and M to P should be the same. Okay. And then from M, you're going to mark off one spot on the circle on either side. Okay. And this C and this D will be our points of tangency. Alright, so if we do a D, that will be tangent. And if we do a C, that will be tangent. Okay. Okay, so that is lab 8. You can go ahead and follow the instructions for lab 8. Let me find what page it's on. Sorry, I should have looked up the page. Okay, so lab 8 is page 387. So notice on page 387, okay, in the lab practice, you're going to do a line that's tangent to a circle called D at point A. So A is on the circle. Okay, you're going to do a line tangent to circle D from point F. F is outside the circle. And then C, F is on a different circle, so F is on circle E. And then for D, you're doing to a different circle, and then G is off the circle. So A and C are the first kind, so they are tangents from a point on a circle to the circle. And then B and D are like the second kind that we did. So these are from points that are not on the circle to a circle. But there's just two different circles, circle D and circle E. So go ahead and follow those directions. Okay. So that should do it for lab 8. And then lab 9, we are constructing regular polygons. Okay, so there's a few different kinds of regular polygons that we could do. Okay, so I'm going to show you a few of them. Okay, so first of all, okay, if I draw a circle, the absolute easiest regular polygon to construct is a regular hexagon. So I will do that one first. So regular hexagon. Okay. So the regular hexagon, after I draw the circle, I keep my compass exactly the same and I don't change it. And then I just pick a starting point. I'll just call that starting point A. And from A, I'm going to go and I'm going to mark off 1, and then go to that spot and mark off an arc, and go to that point and mark off an arc, and go to that point and mark off an arc, and go to this point and mark off an arc, and go to this point and mark off an arc, and I'm back where I started. So I have 1, 2, 3, 4, 5, 6 equal arcs, and if I take and put chords that join the end points of those arcs, there, 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 and there, I will get a regular hexagon. Okay, so you can see why a regular hexagon is so easy, because all I have to do is just draw. I never change my compass. I draw the circle, I leave my compass, I just mark off 6 arcs, and I'm done. I never even change the compass at all. So this A, B, C, D, E, F will be a regular hexagon. So you can imagine, okay, a regular hexagon is really easy, and a regular triangle, okay, if I wanted to use the circle method, I could make a circle just like I did before, and then go on, mark off 1, 2, 3, 4, 5, 6 arcs, but for a triangle I'm just going to join every other one, so I only get 3 sides instead of 6, and that could give me a regular triangle easily. Of course, there's an easier way to make a regular triangle, sort of using kind of the whole side congruency thing, but this is how we're going to do it in this lab. Okay, so there's a regular triangle. So, you know, this is just as easy as this one, okay, because we're using the same points, we're just connecting every other one. Okay, closely related, so those are easy. Let's go ahead and do a square. Okay, so now I'm going to do a regular quadrilateral. Okay, so a regular quadrilateral. All of these you'll see are going to start with a circle. So the regular quadrilateral. Oops, I lost my center. That's not good. Okay. And you want to start by, you know, finding the endpoints of a diameter. So I'm going to mark off the endpoints of a diameter. So I'm going to call those A and C. Okay. And I'll lightly pencil that diameter in there. Okay. And we know that a square is a rhombus, and so we know that the diagonals of a rhombus are perpendicular to each other. And so this is the diagonal of my square, and the other diagonal is going to have to be perpendicular to it. So basically what I need is a perpendicular through the center to this diagonal. Okay, and then that will give me the other diagonal, and then I can just connect the two. Okay, so I need to do a perpendicular bisector of diameter AC. Okay, so I'm going to open up and put an X above and below from C, and above and below. from A. And then if I were to draw that perpendicular bisector in there, then this B and this D would give me the other points that are on my square. Alright, so if I connect those, that will give me the perfect square. Okay, so ABCD is a square, and all you had to do was one perpendicular bisector. So you did have to change your compass opening to slightly harder than the hexagon and the equilateral triangle, but again, not too bad. Now, if you wanted to draw a regular octagon, okay, it's going to be related to the regular quadrilateral. So let's do a regular octagon. Okay, so once again, we're going to start with a circle. Okay, and draw your diameter in there. I'll just call it A, B. Then you're going to make a perpendicular bisector just like we did previously. So I'm going to do above and below from A, or sorry, from B, and above and below from A. Okay. Okay, and now basically if I were to bisect each of these angles in here, that would give me the central angle that I need for an octagon. Okay, now I'm not going to do all of them. I'm just going to do one of them and then get the right lengths and mark them off. But that's kind of the idea of what we're doing here. All right, so I need to bisect this right angle. So remember that the way that I bisect an angle is I would have to draw an arc, okay, here that crosses both sides. I already have one. It's a circle itself. And so from the one ray of the arc, I'm going to make a nice big arc out here, and then from the other end I'm going to make one. And then if I mark hook up my X marks the spot with the center of the circle. Okay, that will be the angle bisector, which means that this point right here is one of the, so from A to that point right there will be one of the sides of my octagon, and then from, let's call this C. So AC is on my octagon and AD is on my octagon as well. Okay, so this is one of my sides, AC, and this is one of my sides, CD. Okay, well now that I know how long the sides are, so if I go from C to A and measure that, I can just kind of mark those off. So there's that one, and then there's that one, and that should be right on, and then there's that one. Okay, and so that will give me the sides that I need for my octagon. Oop. Almost done here, and my last one. All right, so there is my regular octagon. Okay, so the last one that we're going to do is a regular pentagon, and that one is tricky. Okay, so the regular pentagon, okay, and you might want to actually write down the steps for this one as I say them, because they are this is a little bit tricky. Okay, so we're going to start like we did before by drawing a circle. Okay. And then the first thing we're going to do for step 1 is draw diameter AB. Okay, so obviously it has to go through the center. It doesn't matter where you put the diameter, just anywhere, but I'm going to draw diameter AB. Okay, so this is AB. And then the second thing I'm going to do is draw the perpendicular bisector. So the perpendicular bisector of AB, and label the X on the circle where the perpendicular bisector intersects the circle. Okay, so this is sort of what we had to do with the square. So this is no different than what we did with the square. So I'm going to do the perpendicular bisector of AB. So I'm going to open my compass wide, do an arc above and below from B, and an arc above and below from A. And then I should have my perpendicular bisector if I mark it to. And so I'm just going to draw that in very lightly, but the point that's important is this one up here. I'm going to label that X. So where it intersects the circle, I'm going to label that X. Okay. And then I'm going to find the midpoint of AP. Okay, so AP is the radius of the circle. So AP is the radius. And I'm going to find the midpoint of it and label it Y. Okay, so to find the midpoint of AP, once again, I need to do a perpendicular bisector. Okay, but this time with A and P. Okay, so I'm going to go above and below from P and above and below from A. And if we connect the two X's, there's my midpoint right there. I'm going to label that Y. Okay. All right. Next, I'm going to measure the distance from X to Y with my compass, and I'm going to mark off that distance on diameter AB. Okay, and label that point Z. Okay, so I'm going to measure the distance from X to Y. Okay, there it is. And then I'm going to mark off on diameter. I should have said from Y. Okay, so I'm going to mark off from Y, measure X, Y, and mark off, okay, from Y on diameter AB. Okay, mark off. So here's X, Y. I'm going to start from Y and mark off on the diameter and label that point where it crosses the diameter Z. Okay. And then I'm going to construct the perpendicular bisector of PZ. So the perpendicular bisector of PZ. Okay, so here's P, here's Z. So once again, I'm going to open up nice and wide and do above and below from Z and above and below from P. We should be good at these perpendicular bisectors. Okay, in this one, I'm going to go ahead and draw that perpendicular bisector in. Okay, and then label the points on the circle C and F. So C here and F here. Okay, so BC and BF are sides of the pentagon. Okay, so if I connect B and C here, and if I connect B and F over here, those will be sides of the pentagon. And so if I want the other ones, just like I did with the octagon, I just need to measure one of these. Okay, and then I can mark off from C here. Okay, it should, if I'm pretty close. My pencil's getting pretty dull, so I'm not perfect, but it should be very close to being correct. Okay. All right, and so that will be your pentagon. One thing to note is that if you try to go to lab 9 and follow the directions in your book, they're just wrong. Okay, you will not get a pentagon if you follow the directions from lab 9 in your book. You must do it this way, as I've told you. You're not going to get a pentagon with the directions from lab 9 in your book. Okay, so hopefully you wrote these down. Go ahead. I would like you to go ahead for lab 9. I want you to do a regular triangle, a regular quadrilateral, a regular pentagon, a regular hexagon, a regular octagon. Okay, so all of the ones that I showed you, the triangle, the quadrilateral, the pentagon, the hexagon, and the octagon. Okay, your lab 9 says you should try to do a dodecagon. That could be fun, but just these 4 is good enough or just these 5 is good enough for me. Okay, so enjoy, happy construction.